We have this built-in assumption, right? New equals strong. A new car, a new phone, and especially a brand new building. You see that gleaming structure, all steel and concrete, and you just think, wow, that thing is solid. But what if that's not just wrong, but dangerously wrong? What if a new building is actually hiding a major weakness from the moment it's built?
So that gets us to the big question here. Is that towering new building actually as strong as it looks? Or is it kind of just pretending, going through this fragile, awkward phase until it really grows into its strength? The answer is, well, it's pretty fascinating.
To figure this out, we have to go right back to square one, to what we can call a building's fragile beginning. We're going to take a look at the secret life of these structures and why the strength you see on the surface, well, it isn't even close to the whole story.
So the whole idea behind this is a concept engineers call gradual strength gain. And it's pretty much exactly what it sounds like. Building materials, especially something like concrete, they don't just become rock solid the second they're poured. Nope. They have to go through a process, almost like maturing, where they slowly, over time, harden and gain the strength they're actually designed to have.
I love this analogy because it makes it so obvious. Think about baking a cake. You pull those layers fresh out of the oven. What happens if you try to stack them up and dump a bunch of heavy frosting on them right away? Total disaster, right? You get a warm, gooey mess. You have to wait. You have to let those layers cool down and firm up. A massive building, believe it or not, is pretty much the same.
And this really lays out the two extremes. First, you've got that early stage concrete. It's weak, it's vulnerable, and it needs all that scaffolding and external support just to hold its own shape. But then, after it cures, it becomes what we all expect: strong, stable, and completely self-supporting. It's a massive transformation, and the secret ingredient is simply time.
Okay, so if time is the key, what happens when you rush it? Well, that's where things get really dangerous. We get into something called a chain of errors, where just one little mistake can spiral into a potential catastrophe.
And it all starts with this one simple but absolutely critical idea. Wrong sequence causes uneven loading. All that really means is doing things in the wrong order. Imagine trying to drop a heavy roof onto a house before the walls are fully set. All that weight gets distributed incorrectly, and you're putting a ton of stress on parts of the building that just aren't ready to handle it yet.
This kicks off a terrifying domino effect. First, you get the sequence wrong. That immediately leads to number 2, the uneven loading we just talked about. Then, because things are rushed, that often leads to step 3, pulling away the temporary supports way too early because you think the structure can handle the load. And the final domino to fall? Permanent, irreversible damage to the building's very core.
And here is the most chilling part of this whole thing. This damage is very often completely invisible. The building can look absolutely perfect from the outside, but during that brief moment of instability, its core elements, the actual bones of the structure, have been stressed, weakened, maybe even cracked in ways you'll never see. It's a hidden flaw that can compromise that building's safety for its entire life.
Okay, so that's the scary part. How do we avoid all that? Well, luckily there is a blueprint for strength. There is a right way to do it, and it all comes down to that key idea of sequence.
The entire solution is captured right here. Proper sequencing ensures structural safety. It's all about having a plan and executing that plan with patience and precision. You can think of it like a carefully choreographed dance, where every single piece is added only when the structure is absolutely ready to bear its weight. This is the path to stability. It's the mirror opposite of that domino effect of failure. You start by following the design sequence to the letter. This lets you manage how the load is distributed, nice and evenly. Then, and only then, do you time the removal of the temporary supports perfectly, right when the materials have gained enough strength. The result? You get a building that achieves full structural integrity, just like the architect designed.
And here you can really see the two paths right next to each other. It's a showdown. On the left, the wrong sequence. It's just a recipe for chaos and hidden damage. And on the right sequence. That's the blueprint for controlled loads and safety that lasts. It's the same materials, the same design, but the process makes all the difference in the world.
So why does all of this matter so much? Well, because this isn't just a lesson about putting up a building. It's really about recognizing the invisible logic that's holding so much of our world together.
If there is one thing you take away from all of this, let it be this. A building's real, long-term safety isn't just about the strong steel and concrete you can see. It's in the intelligence of the construction sequence, the when and the how everything was put together. That's what really counts.
So let's do a super quick recap. We've learned that structures have to earn their strength over time. We've seen how getting the sequence wrong creates dangerous, uneven loads.
We know that pulling supports away too soon can cause permanent, hidden damage. And finally, that a proper, intelligent sequence isn't just a nice idea, it is the absolute key to structural safety.
And that leaves us with one final thing to chew on. We've just seen the invisible logic that goes into building our world. So it makes you wonder, right? What other unseen rules and hidden processes are quietly working in the background just to keep our complex, modern world standing strong?